So there are times we like to evaluate functions at given values. They're useful in creating XY tables, it's useful when we want to know domain and range, it's useful in so many applications. And so a thing to remember is that in this type of notation, f of x is another way of saying y equals. I think this one's a little more useful because it tells us what we're inputting. It reminds us that we're putting something into a function. And depending on what we input, we're getting an output. And so what's in here tells us what we're going to input for x. So for example, if I want to input a smiley face into function f, it's going to go in for x. So I get 2 smiley face plus 3 as my output. Say I want to input 1. Well, function evaluated at 1 is equal to 2 times what we input, 1, plus 3. Or 2 plus 3, which equals 5. So f of 1 is 5. When we're evaluating, we stick whatever's in here for any x's on the other side. So, say given, for example, that g of x equals x squared plus 5x. Well then g of balloon is equal to balloon squared plus 5 balloon. So in both these cases where the x's are, we put balloons because that's what we're inputting. So if I want to know what g of b plus 1 is, I get, well, x, so I put a b plus 1 in for that x and square it, plus 5 times b plus 1. If we wanted to, we could expand this and combine our like terms and make this look simpler. But the idea is when we're inputting or evaluating a function, we input our value in for our x's, we get an output.